Hi there, welcome to Cerp TV. I'm Dr. CPN. Now I want us to talk about something in mathematics we call the radical. Now when you have an equation that looks like this, an equation like this, you see we have x to the power n is equal to a. What are the possible solutions to this equation? You know that equation boils down to we have x to the power n is equal to a, and which implies that if you take 1 over n, you raise both sides to 1 over n, then you have x to the power n raised to the power 1 over n is equal to a to the power 1 over n. And of course, you now have that x to the power n times 1 over n is equal to a to the power n. And then which implies, of course, n times 1 over n is going to cancel out. So I'm simply going to have that x is equal to a to the power n, sorry please, not a to the power n, 1 over n. A to the 1 over n is simply equal to the nth roots of a. And that follows from indices. That should be one of the laws of indices. So whenever you have an equation like this, x to the power n is equal to a, you have 4 possibilities, 4 cases. Number 1, if n, which is the power, is odd, then our solution simply becomes that x is equal to the nth root of a. But if n is even numbers 2, 4, 6, 8. If n is even, then, and we also have that a, that is what is contained within the bracket, is greater than or equal to 0, then our solution simply becomes that x is equal to positive or negative the nth root of a. That is on the condition that a is greater than or equal to 0, the a you are seeing here. Then if n is even and this a is less than 0, negative number, minus 1, minus 2, minus 3, then there will be no real solution, because this of course leads us to the field of what we call complex numbers. So now, having explained this, I want us to run down the solution to these 6 problems as quickly as we can. Remember, you need to know the difference when n is positive, when a is positive, that is greater than or equal to 0, and then when n, whether n is odd or even. So let's solve number 1. We have that x to the power 5 equals to 32. The solution to this problem, for me to get the solution, you simply discover that x becomes equal to the fifth root of 32. Now let's analyze. This is greater than or equal to 0, a positive number, and then this is odd. We don't have issues here. The fifth root of 32 is simply equal to 2. Now we go over to problem number 2. And what exactly is problem number 2 say? It says that x squared minus 5 is equals to 32. Now x squared minus 5 equals to 32. What we have is that x squared is equals to 32 plus 5, which is equals to 37. Okay, beautiful. Therefore, we have x squared is equals to 37, and x now becomes equal to, because this is squared, an even number. 2 is an even number, so we are going to have positive or minus the square root. Because it's square root, we don't always write 2 here, of 37. So that becomes the solution to that problem. We have either plus square root of 37 or minus square root of 37. So that problem has 2 solutions. Okay, beautiful. Now we take on problem number 3 as quickly as we can. We have x minus 4 all raised to the power 2 is equal to 5. Now notice immediately that the power here is 2, which is even. So I have that x minus 4 becomes equal to, so because it is even, I'm going to take plus or minus square root of 5. And I carry minus 4 across to that side, so x becomes equal to 4. Minus 4 is negative, so when it crosses it becomes positive. So I simply have 4 plus or minus square root of 5. So the solution to that problem becomes that x is equals to 4 plus square root of 5, or 4 minus square root of 5. Beautiful. Now we go over to number 4. Number 4 says we should solve for x cubed. We have x cubed is equals to minus 8. Now this is an odd power. We don't have issues with the odd power. It means that x is simply equals to minus 8 all raised to the power 1 over 3, which is equal to the cube root of minus 8. Every real number has a unique cube root. And the cube root of minus 8 simply gives us minus 2. Remember that if what we had here had been 4, say 2 or 4 or 6, an even number, then we will not be able to evaluate this. Because we cannot find the square root of a negative number. We cannot find the root of a negative number when the power is even. Then it leads us to complex numbers. So we talk about number 5 now. Evaluate 16x to the power 4 is equals to 81. Now what do we do? The first thing I'm going to do, I say x to the power 4 becomes equals to 81 divided by 16. 16 comes here to divide. Therefore, what do? I raise both sides. So we now have that x becomes equals to 81 all over 16, all raised to the power 1 over 4, which is equals to the 4th root. We have the 4th root of 81 all over 16. My power here is positive. My power here is even. So because that power is even, we now simply have that x becomes equals to positive or negative. Once the power is even, then it has to come with a plus and a minus. The 4th root of 81 is simply equals to 3, and the 4th root of 16 gives me 2. So that gives me the solution, plus or minus 3 over 2. Then finally, let's just quickly solve the last one. We have to solve 5x to the power 2 over 3 minus 2 equals to 43. First, we carry 2 across the equality sign. So we have 5x to the power 2 over 3. 2 crosses over. We have 2 plus 43, which gives me 45. So we have that 5x to the power 2 over 3 is equal to 45. Therefore, x to the power 2 over 3 becomes equal to 45 divided by 5, and which gives me 9. So x to the power 2 over 3 is equal to 9. Now, to make x the subject, I'm going to raise both sides by the reciprocal of what is here. I have 2 over 3 here. The reciprocal of 2 over 3 is 3 over 2. So I'm simply going to raise here 2 over 3. I'm raising it to 3 over 2 is equal to, I'll raise the right hand side to the power 3 all over 2. And when I do that, this one is going to cancel this. Let's quickly put our solution here. So x simply becomes equal to, on the right hand side, I'm going to have 9 to the power 3 all over 2. And which becomes 9. This is simply going to give me from indices. We have this being equals to the square root of 9 all cubed. Now because it is square root, because I'm finding the square root, I have to put my plus and minus. Square root, the power is 2. And this simply becomes equals to plus or minus. Square root of 9 is 3. So I have 3 cubed. And 3 cubed is 27. So I have plus or minus 27 as the final solution. Thank you so much for watching Cerp TV. Please do well to subscribe to this channel. Bye-bye.